Hi, I'm Asfar Khalid, and I, along with my team, are working on the UK's Engineering and Physical Sciences Research Council funded feasibility study project on measuring mental stress factor in occupational safety in the context of smart factory. We are based in the Department of Engineering, School of Science and Technology at Nottingham Trent University, and PepsiCo Europe is our industrial partner. We are working in the context of a smart factory environment where humans and cobots are working together in a production line. This is supposed to be an active safety industrial environment in which passive safety fencing is non-existent. In such a dynamic environment, occupational safety issues are likely to arise, including the mental stress among the human workers collaborating with cobots. We have set the aim to focus on studying the impact of collaborative robots on occupational health and safety, working conditions, ergonomics, and ease of use. Working with robots can generate additional stress on humans because robots can be stronger and faster than typical co-workers, and they don't provide facial, auditory, and visual cues that workers normally use to predict behavior. So the project outcome will be the association between the mental stress versus variation in collaboration time, speed, task complexity, and robot payload capacity. By studying this, we will be able to define a regulatory framework for the industrial collaborative space design that will contribute towards standard development for mental stress in a cobotic environment. We are aiming to develop guidelines for the designing of collaborative space in the industrial manufacturing systems and to support an advancement of international standard on collaborative robotics. And also to develop the guidelines for evaluating working conditions in the collaborative environment and human resource development requirements in the context of British manufacturing and Industry 4 era. So, in order to achieve this, we have designed the experiment in which we are using collaborative robots and the data acquisition system to measure the cerebral activity of the participant while the participant is working with cobot, just like industrial workers remain busy with their tasks in the automated environment. We are using EEG, in which brain electrical potential detects the neural activity from the voltage differences between electrodes placed on the scalp. The other technique in combination is the functional near-infrared spectroscopy, which is called FNIRS, that detects changes in cerebral blood flow and related human hemoglobin concentration, increase in heart rate and heart rate variability, which is a measure of the variations in the time intervals between the heartbeats, can also be affected by stress. These two factors can be measured from FNIRS signal. As another physiological measure, we analyze heart rate and heart rate variability for each episode of task and the rest separately. This way, stress can be identified and correlated to the levels of cognitive workload, sustained attention, vigilance, stress, drowsiness, and effects on verbal and spatial memory. As currently we are performing the experiments, these are some of the previous results. The scalp topographies are representing specific EEG frequency band powers that were averaged over a number of participants in baseline, rest, and task episodes. The participants were sitting relaxed with closed eyes during rest episode. In the task episode, participants were performing a basic manual task, while for the baseline episode, participants were performing the secondary auditory task alone. The auditory task is employed as a loading task to assess the effect of additional stress. It provides a cognitive load matrix as well as it is used to increase the primary task complexity. So different frequency band waves are generated in these output signals. Alpha activity is higher during the rest episode in comparison with baseline and task episodes where participants were performing a task with their mental workload and their mental workload was higher. On the other hand, the beta band power is higher during task performance than rest episode. This indicates the negative correlation between alpha and mental workload and positive correlation between beta and mental workload. So Based on this rationale, the experiments are designed for 40 healthy adult volunteers in one main trial to perform an object pick-and-place task and co-working with robots. Each experimental session is approximately designed to last for an hour. That includes the total time spent by participants to perform the tasks. The Stroop task is a standard psychometric task that has been designed as the main task for the participant, in which the color of the ink has to be considered for decision rather than the printed name of the color. So 40 wooden cubes with the name of the color printed with a non-matching color on each cube are provided for Stroop task. For example, the label red may be printed using color green. It typically takes more time and cognitive effort to identify the color of the label. So the cubes are placed in a marked area on top left corner of the workspace. The cobot Stroop task is designed in a collaborative manner where the cobot picks up a cube and passes it to the participant. The participant takes a cube from the cobot and places it in the marked area on the working table based on the printed color on the cubes. If the speed of participants in performing the task is slower than the cobot, they may not be able to take the next coming cube from the cobot. Therefore, the cube moved by the cobot may be dropped on the table and counted as an error for participants' performance. The cobot Stroop task has to be performed under different speeds of cobot motion, cobot payload capacities, and task complexity from low to high, where the combination of these factors leads to 8 different conditions called episodes. So we have 8 episodes in total. In order to add complexity to the cobot Stroop task, a secondary task is added simultaneously. In this case, the task complexity is high. Participants perform the secondary task by pressing down on the foot pedal, and in response, a series of beeps generated with the duration range from 500 to 1000 milliseconds. The secondary task is an auditory task employed in this study as a loading task to assess the effect of stress on the primary cobot Stroop task. It involves the operator's ability in response to the auditory stimulus, while reaction time and detection rate will be recorded and considered as behavioral measurements. This design is close to the industrial environment scenario where sometimes human workers must deal with multitasking and handle simultaneous demands. EEG and Effner's data collection started by performing the secondary task alone for 2 minutes, followed by performing the cobot Stroop task for 4 minutes. Episode 1 is considered as a baseline where the cobot motion speed, payload capacity, and task complexity is set as all low. A rest episode is then taken for 2 minutes. Participants in rest episode calmly sit on a chair with eyes closed for 2 minutes. Following the first rest episode, participants perform the cobot Stroop task based on the identified episodes in table one after another, starting from episode 2. The NASA TLX questionnaire is a standard form that estimates subjective mental workload and stress assessment by considering 6 established factors, that is mental demand, physical demand, temporal demand, performance, effort, and frustration. Each factor has a score ranged from 0 to 100 in increment of 5. In this study, participants will be asked to fill the NASA TLX questionnaire after completing each task episode, and the average of the 6 factors will be considered. Currently, we are in the data collection phase in our study and looking for results after further necessary data processing. So in summary, the experiment design is based on the combination of subjective, behavioral, and physiological measures acquired during the laboratory test, including robotic arms. The effect of imposed stress according to cobot's motion speed, payload capacities, task complexity, and time on task are considered. The pick-and-place task, Stroop test, and auditory secondary tasks are combined to simulate the real industrial environment and activities. Our industrial partner is interested in enhancing the level of automation on their factory floor and introduce more collaborative robotics as part of their industrial processes. So thank you very much, and now I'm open for the questions.